Does your project directory look like this? A flat pile of files where the logic, the headers, and the tests and the binaries are all fighting for space? In a university project, this is fine, but in a professional environment, this is called source pollution. You're violating the core principle of separation of concerns. Most tutorials teach you how to write code, but they never teach you how to build a product. In this video, I'm going to show you the 3-layer separation that senior devs use to turn this junk drawer into a production-grade system. I remember when I started working at my first company, I didn't really have a good idea of what a professional codebase looked like. But when we did a Git clone and I was able to see our projects for the first time, I was really amazed and I thought it was really cool how everything was organized. The more I worked with these codebases, the more I started to see an overall structure of how this codebase was put together. And the more I did that, the more I admired how the senior engineers put this codebase together. Because when someone would ask me a question like, how does this feature work? Then I would know exactly which folders to go into and then which files to check. And then I would eventually be able to figure out and narrow down which functions contributed to that feature. It was at that moment that I realized that being a senior engineer doesn't mean just that you know how to code or that you have really good logic or you know how to implement something, but it also means that you have good architecture. And so if a stranger was to come by and look at your code, they could easily navigate your code in 60 seconds. So I'm going to go over 3 layers of separation for how you can separate out your code so that it's a lot easier to manage and navigate. My name's Henrik and I've spent the past 13 plus years in software engineering, and today I help software engineers who feel stuck and overwhelmed with the growing tech industry and help them build the core foundational skills that they need to stay relevant heading into the future. Okay, let's go back to this code and apply the layers of separation here. So the first layer of separation is called interface, and basically what we're going to do is we're just going to create a folder or directory called include. And this is commonly known as the folder that has all the header files. So we just put all the header files here. Okay, so the header files are all here, and it can just look like a folder where you just put all your header files in. And what's nice about this is that you can look at the header file and see all the functions that are implemented. So these are all the functions that are implemented. You can see what return types there are, and then the arguments, and then there's also a struct here. And sometimes the struct will have the whole structure defined here. But we have it like this because what we also want to do in this header file is we want to protect how the structure is defined. But one advantage of doing it this way is if you look at where it's defined. So you have the struct here and all of the functions that are related to that struct are implemented here. And the reason why this is done this way is because you want to put all of the implementation in one file here. And then you don't want to have anything in the header file that could mess with the implementation. All of this is part of this idea called encapsulation. So in this idea of encapsulation, what the header files do is they define the what. So they define what is allowed in the program or application. And then in the C files, it defines how it is done. So the idea behind this layer of separation is not just that we put the header files in the include, but also that another developer can look at this and be able to see what the system does or what this library does, but they wouldn't know how it works. Now, why wouldn't I want my teammates to know how something works? It's not that I don't want my teammates to not know how something works, but rather I'm separating things out. I'm separating them as this is where you can see all of the functions and you can see what the system is actually doing. But if you don't want to know the how, if you want to know how everything is implemented, then you can go into this other layer, and that is called the source layer. So in this source layer or implementation layer, basically it's just the source code, so you can see how everything works. So we're separating it out. This is the interface, and then we're going to create another folder called src. Okay, so I put all the C files here, but I left this one out because this is not actually part of the project or part of the product. So this source directory has all of our C files, it has all of the implementation, and the implementation is also separated by its role. So the connection.c handles all of the connection type actions in the program, and then the parser has the function that parses the packet. And the utils.c is just some utility functions for the developers to do some debugging. So there's a logic in why we have different C files. So if you look at the main file here, we have the call for the utility functions here, and the log info, log error. And then we have the connection functions here, the net connect, net send, net disconnect. And what's nice about this is, say we had a bug in our program, and then someone was saying, I think it has something to do with the connection. I think I'm suspicious about the connection. Then we can just go to the connection.c file, and then we can see if there's some sort of bug here, and we can do some checks here. We can also use our utility function calls here to diagnose what's going on. Another benefit of having these C files defined like this, and then the header files in here, like this connection H, parser H, util H. What's nice about it is that, say we're in the connection.c, and then we want to do some logging, we don't have to actually go to the utils.c file to actually see how it works. We can actually just go to utils.h and see which kinds of functions we can use to log our errors or log something in the connection.c. We can just look at the utils.h, and we don't even have to care about the implementation. It's kind of like a black box. We can just see that we can use this function, and then maybe some other developers in charge of the utils.c or some other developers have developed that already. I don't have to know how it works. I can just call it here, and then it does what I wanted to do. And so it helps me narrow down, and it helps me not get too distracted on what's going on in all of these other C files. So I hope you're starting to see the value here and starting to see that this is actually a really high IQ way of structuring your code. And speaking of high IQ, I have a high IQ software checklist that you can download, and it's a free checklist guide that you can use to audit your own code bases. So you can just go through this checklist, and then you can see, is there a way that you can improve your code to make it more high IQ? So you can download that guide in the link in the description. Alright, now let's go into the third layer of separation. So in this third layer, we can see here that we have an executable called mytool here. So this is an executable that's built if you're just doing GCC, and then you link all of your files together, and then you create this executable. But instead of using GCC to just create an executable that's just hanging out here, what we want to do is we want all the build files, all the artifacts to be stored in this new folder called bin. The way we achieve that is by creating something called a makefile. Okay, so this is our makefile. Here we specify the compiler and then the flags, and we need this flag here to say that we're going to use the headers in this include folder. And then here's the target. We create a directory called bin and then put our target in there. This is going to be our executable for the program. And then this is the default rule over here. When we run make, we create the directory bin, and then we create the target. So run make here, and then it built, and then you can see the bin folder was created. So here's our object files here, and then our executable is here. And then we can actually run the executable. We just do bin mytool, and then there you go. Starting network tool, attempting to connect, sending data, and then disconnected. And then we can also use our makefile to clean our directory, and then when we do that, it removes the bin directory, and now everything is nice and organized. Let's run make again so that we can have all of the layers of separation. So we have, just to recap, we have include here. This is going to be our interface. So this will have all of those functions and those structs that we can use on telling us what the system can do, what the program can do. And then we have the source code. This is going to be where all of our implementation is done. And we don't, as a programmer, if you're working on a team, like I said, you don't have to worry about, if you're working on this file, you can just worry about this file alone. You don't have to worry about what parser.c is doing or utils.c, because the logic for those and their purpose in the program has been separated out. Okay, we forgot about this test connection.c. So what we do with this one is we create a new folder called tests. And this folder is just for all of our tests. So maybe we have some unit tests that if we want to do some unit tests for some of these functions like netconnect, we can put them inside this tests folder. So this is just for testing our code, making sure everything is still working, and having some unit tests. So we can test out our program, make sure everything's still working as people are doing development on it. Alright, so there you go. We've organized our code, we've structured it. So we have our include for all of the header files and the interface layer. We have the source code, which is our black box layer. And then we have the tests, which is our test layer. And then we have bin, which just has all of our executables and object files. So now you can see that this is a lot more organized, and now it's easy to navigate. And sometimes in my companies I've seen we would have multiple libraries, and each library would have this sort of standard project structure. Alright, that's it for this week's video. I hope it really helped you out and gave you some ideas on how you can start architecting your code. And if you would like more help on how to architect your code, you can download my High IQ software checklist. It's a free checklist guide that will help you look at your logic, your system architecture, and also your professionalism and security in your code bases. And so you can use this to audit your own code bases and see how you can improve your code bases to make them look more professional. Alright, thanks for making it to the end of the video. If you have any other questions, feel free to let me know in the comment section and I'll be sure to answer you there. And if you want to watch another video on how to be more professional in your coding, you can watch this video over here, and I'll see you in the next one. Peace.